This is a joint presentation between me and Holger. And so we are doing a project at Volkswagen for containers in automotive.
I think, Gunther, you can be proud of being in the realm of these making containers like first-class citizen. I think in automotive you are leading edge here, and
So it's similar to this morning's presentation. So for CAE, this is our target group. It's computer-aided engineering. So we really need to run existing applications and new applications on the same hardware. So currently we need to run the bare metal applications like we have done all the decades before. And in parallel, we also enable HPC applications in containers. So we have this software stack and also the reliance on software vendors' codes. And also what we are seeing now, similar to the other presentations, the system group is a bottleneck for innovation. So we want to give this also to the hands of users who want to do it themselves. And we also feel the problem if a user then creates his own problems, it's not as easy to debug, because if for the curated images, there's a group which looks at errors and tries to improve things. But anyway, we need to do this because the complexity is just increasing and users want to create their own workflows. And also, this still is valid. I showed this already last year, the lifecycle management I emphasized this morning. And also, I think the empowerment of users is something new, because this can be easily done with containers. So it's probably not for all users. There might be users who just use the default version and do not so much experiments. But we have users who are eager to try new things. And so with containers, they can do it on their own base.
But maybe, I don't have a rule, but like just to back in here, it's one thing is empowering of users, right? Empowerment of users, but it's also like shifting responsibility over to the user, right? It's a good thing, and it's also kind of a bad thing, right? Do you think that levels each other out? Or?
So there will be two types of users. One with the curated images, you have a support group, and the advanced users who need to take the responsibility. And of course, we will try to help them if they run into problems which are caused by containers.
This is a quite different area than your typical, your typical scientific users. So the origin story of Singularity, which Greg gave, that Singularity was created by bribe and threats and whatever, is just typically not true for these environments, because the users typically just call the admin and say, okay, I need this piece of software, a new version of that. But what we're seeing more and more these days is that it's nice for some, some researcher inside the company, or some really advanced user, or containers as a method to bringing new additional workloads coming from the AI/ML field, for example, and having then the possibility to enable this compared to before, where you're sort of dependent on your administrator, is really enabler here. No, it's your time.
And also we want to reduce the time to deploy, because currently if the central group deploys an application, it takes time, because they need to install it, and many things happen by hand. So with the container recipe, you can just take the new version and have all the customization then in this Docker file, which will also be made available to the users, so they can change several aspects. So this will also democratize IT workflows, because the bottleneck of the central group is removed. And also, I think we want to see synergy in Volkswagen Group, because each brand has their own HPC installation. So this is probably similar to academics. So it's not easy to take a job which runs in one lab and let it run on another lab. And I think there is still more to do, like now everybody invents his glue for this. So we have our own glue, like 100-line shell script. And you have to adhere to some conventions, like you do not mount yourself the data, but this is done from the outside. So all data is already available when you start the container. And so this is just where we start. So probably there are so many options now, and I also look forward to have a more standardized way for doing this, besides of the Kubernetes way. We also don't want to use Kubernetes. But if a user puts Kubernetes into his own container, he can use it. So. And last but not least, I think it's a security improvement, because you are inside the container with limited access to the file systems and network and all these things. So now I would like to hand over to. No. Ah, okay. So one last slide, an update from last year, which I said it's the year of the HPC container. I think many things happened now, so many are now trying to really put in production. That's like we. So in this year, we will go live with selected applications. So new versions of these applications will be installed by our central group just in containers. And it's also hidden from the end users. They just have their normal interface. And in the background, there is a switch for the new version which uses the container. And also we see it as an enabler for AI applications, because the AI users, they already have containers. So it's a natural match to just bring their containers and run it on HPC.
And typically different operating system inside the containers.
Yeah, it's just a black box, and they need to take the responsibility for their own black box.
No. So yeah, the idea was, when embarking on this journey, to somehow give some remarks what we've seen, not necessarily only when working with Volkswagen, but also with other users. So what we already talked about is the users, and this is quite crucial. That I wouldn't go so far and say that typical industry CAE users are sort of spoiled, but you don't necessarily see that they're super cheering about containers, that it's a total no-brainer to introduce them in their environment, because at the end of the day, they typically just want to work. And if they are not like your very superpower user who wants to do everything on his own, they prefer to call an administrator. So why this is important is that if you want to sort of copy this strategy and introduce containers at scale at some enterprise HPC environment, you need to make sure that the users are aligned with the strategy, that they see the benefits of containers. And for most, when speaking to different customers, it's not always that much about enabling them to run their own software in their environment. But what Gunther already showed is, what a selling point for them is that often in containerized environments, you get the benefits that your user land is stable, all the regression things. And this is for the users often, in my experience, beyond Volkswagen, a bigger worse than being enabled to do so. While I still think that this is totally legit and is pushing the way forward here, but not necessarily for all. But so make sure that the users are aligned with your approach. Then what we also see with other customers than Volkswagen here is that many just think, okay, I have this list of CAE applications. I'm just going to build like a container for each application like one time and then be done forever. And this is just not true, because in the world of CAE, applications typically just get released multiple times a year, and then you're bound to provide this new version. So the point here is just make sure to build for more than one time build, that you automate your building as far as possible, that you have the related CI/CD infrastructure around this, and also make sure that you must basically support 3 different constellations. On one hand, the fully self-built images, where your power user can come along and build their own thing. that what we are hoping to see more is that more ISVs than now provide, at least if they don't bring a dedicated image already, that they at least provide a Docker file how they would want an image to be built. And I mean, the ideal world would be, of course, if an ISV provided their container images, like fully supported with them. But even this, what we see in many environments is that they still would want or would need some kind of modification here and have some customer-specific code included, which is totally fine and works, but which would still have to be done. What we also see is that many customers don't think that much about how they would want to provide the images in their environment. They think, okay, well, I have this registry server I'm pushing from my CI/CD pipeline to, and that's it. And the compute jobs are going to be to pull here. And I mean, most enterprise HPC environments are globally distributed. And so you must make sure that you have some kind of mirroring infrastructure or a different approach like what you are having, a peer-to-peer network just for the image distribution. But I think we could give a dedicated talk on this next year maybe. But this is also something I'd be interested to learn what the large-scale HPC sites are doing. And how they're implementing their image distribution approach here. Because I think you did the math that in the worst case scenario, you would pull 60 terabyte per day from a poor registry server, which is just a bit obscene for the ones who are regularly or typically providing this kind of service, and the microservices, and then the CAE container is a quite different thing. And what I also would recommend is make security part of the journey as early on as possible. I'm not really aligned with the NIST publication about security for HPC that basically states that containers is like a new threat or something. I see this as a great opportunity to improve the state of art in HPC security, that there are multiple benefits. I'm speeding up. You can benefit from here with software bill of material, that you can scan for vulnerabilities and all that, and even advanced features, and that you have at least quite decent level of isolation here where it's applicable. And what you also can quite easily do is have a stronger separation of code and data than you have in your typical enterprise HPC environment, where you have usually large amounts of data accessible over network. And in a container land or container approach, you would just typically just hand in your computation-related data for this very specific job. And so you would also like limit the blast radius if something went wrong here. And we have image signing as another possibility here. Some of the things could also be done prior to containers, but they greatly simplify here. For example, what we're doing, this is basically the last slide. What we're doing here in another project is that we are leveraging container features, that there's some image introduction process that typically originates from the certain validation if a new application is, in terms of function, doing this, what it should do. And with the approach we took here with some additional containers running alongside the application, we are able to scan alignment of the application with overarching network security policies, like, for example, that the application is not allowed to snoop around in the network or start services or stuff like that. And this is really nice to do, or much easier to do with containers than before. And this could be easily extended. For now, we're just focusing on containers. So to summarize the whole thing, containers in enterprise and introduction at scale is not really a sprint, but a long-term investment, which will hopefully, from my experience or from my judgment, will pay off. And even if the users do not or should not benefit directly in terms of stabilization of the environment and debugging possibility, this can greatly help here. And that you can just open up your environment to additional user groups and workloads. And don't be scared of security in containers, okay? Yeah, user namespaces, people are quite hesitant there, especially when running an HPE system. But anyway, the last point here is that we hope, or still hope, to see a growing possibility for ISV-provided code straight from the vendor, and reduce the effort to build images on your own.